When you are asked to calculate the slope from 2 points, that's the same as being asked to find the rate of change from 2 ordered pairs. Just when we're using this terminology slope and points, we're thinking about those 2 ordered pairs plotted on a coordinate grid, like in this sketch right here. So when we're asked to find the slope between those 2 points, we're going to use the definition rise over run, which is really just our graph way of looking at how much y is changing and dividing it by how much x is changing. So just like slope is the same as rate of change, slope is just our word when we're talking about a graph. Rise over run is how we look at delta y over delta x on a graph. So if I plot these 2 points, 2, 1, and 4, -3, I'm going to find the slope between them by finding the rise, how much y is changing, and dividing it by the run. Looking at these 2 points, my y values, my y coordinates are 1 and -3. So my rise will be found by looking at how much y is changing. When I go from 1 to -3, I'm going down 4. That is my rise. Y is decreasing by 4. Then when I look at my x coordinates, that allows me to find my run. How much is x changing? X is changing from 2 to 4, going up 2. So rise, -4, run 2. That tells me when I look at my coordinate grid that my slope is -4 divided by 2, or -2. So that's one way to find the slope between 2 points. Plot them on a coordinate grid, look at the y coordinates, how much y is changing, the x coordinates, x is changing. Generally though, and particularly if the coordinate values are really large, we won't want to actually plot them. We'll want to use one of these 2 methods. We can make a mini table, which in Algebra 1, that is my preferred strategy. So a mini table including those 2 ordered pairs, 2, 1, and 4, -3. Now that I have my mini table, I can use this definition. So instead of thinking rise over run, since it's not a graph, I'm just thinking delta y over delta x. How much is y changing? It's going down by 4. How much is x changing? What's my delta x? X is going up by 2. So then just delta y over delta x, change in y over change in x. That is -4 divided by 2, which again gives me a rate of change, same as a slope, of -2. When x goes up by 1, y goes down by 2. X goes up by 1, y goes down by 2. I could fill in this in-between row here to see that. When x is 2, y is 1. When x is 3, y would be -1. X is 4, y is -3. So mini table. This is, I'm going to highlight it as my preferred strategy. The reason this is my preferred strategy is students are much less likely to make mistakes with negatives. You know that when we go from 1 to -3, we're going down 4. The second strategy, which is using the same idea, is the slope formula. The slope formula, we take the 2 coordinates, we look at the y coordinates first, subtract y1 from y2, so y2 minus y1, y2 minus y1, -3 minus 1, and then we subtract x1 from x2, or x2 minus x1, 4 minus 2. That gives me -4 over 2, or -2. If you look, we're doing exactly the same computation here. -4 divided by -2. We're seeing how much y goes down from 1 to -3. This is just students are more likely to make a mistake with their integer operations. It's fine if you want to use the slope formula, but it's just a little more risky in terms of computational mistakes. One thing to note is which coordinate pair or which ordered pair we define as x1, y1, x2, y2 is totally arbitrary. I could have said 4, -3, and 2, 1 was my ordering, so that 4 would be x1, -3, y1. 2 would be my second x coordinate, and 1 would be my second y coordinate. And I could have used the slope formula here. So I could have done x or y2 minus y2 minus y1 So 1 minus negative 3, and then 2 minus 4. Now I'm going to get 4 over negative 2, but I'll get the same rate of change, negative 2. So it does not matter in which order you define x1, y1, x2, y2. You just need to be consistent. y2 minus y1, x2 minus x1, or y2 minus y1 divided by x2 minus x1.